Hello everyone. So today I kind of want to get into something a little different. Yesterday we did some live world building stuff. We might still do that today, but I'd like to add a bit more color to my face for a moment. There we go. Yeah, so okay. I should show my desktop for this, but there's a really cool music procedural tool called Buzz Tracker from like the late 90s, which got kind of revamped in 2008 and on. But it is a really interesting way of writing procedural music using nodes, charts, and graphs. Actually, let me show you what I'm talking about. So, and I'll show you why I think that's kind of cool and what I want to do with that today. So this is Buzz Tracker. So it takes a tracker interface. So if you've never worked with a tracker, it has samples down one side, and then it's almost like a spreadsheet, but the spreadsheet's split up by timing. And in there, you punch in the notes and the volume and the sample. But what I loved about Buzz Tracker is it's a node-based, graph-based tool that lets you take your mixer. Well, everything goes into the mixer at the end, but it comes through all the different sound sources, and you can put all these really cool delays and custom effects, and it gets to be super cool. That said, I think they lost the original source code. They rewrote it, and it's kind of an interesting tool. But I was thinking the other day that as cool as the tool is, and it does crash relatively easy, it would be kind of cool if I could make something of my own that could do something like that. And then I started thinking, well, we have the power of Unity, which can do graph-based plugins really well, and it can do audio pretty well. So what if I spend a few hours and we just do an experiment? So we're going to sit with Unity. We're going to try to create a graph-based audio solution, and we'll move forward from there. So it's going to be split into two parts, well, three. There's going to be generators, there's going to be effects, and then there's going to be usually kind of a miscellaneous handling. But the other thing that we kind of got to think about in this process is unlocking the tools. So one of the things that made Buzz Tracker super cool is the fact that all of the audio doesn't get limited. So you could really do some really complex and interesting things. The delay would happen according to timing on left and right channels. You can control it independently. You could use feedback to create new sound effects that come out of it. And it was just a very different way of being able to work with sound and audio. So today I thought, let's sit down, take Unity, and see if we can't build our own version. Yeah. So I guess let's open Unity. So I'm going to create a new project. I'm going to stick to 2019. We'll call this Procedural Audio. This is set to 2018.4. Do we want 2018? Let's do 2019.4. And let's call this Procedural Audio Nodes. I'm going to keep it 2D. Well, I guess 3D is fine. It's just an empty project. It's stuff we're going to probably do mostly through the editor. And the reason I thought I would do this as a live stream versus like to show you live while we work on it is I didn't want to have one of those tutorial videos that shows you everything in 10 minutes. because they don't really show you the learning process, and sometimes I think the learning process can be a little bit fun. So with that said, let's move my picture down to that corner and let Unity come up. So we're going to need to do two things. One is, first, let's see if we can't generate some noise. Yeah, I'm also going to be quite surprised if anybody attends the stream, given that it is a holiday and hopefully people are getting time with their families and doing that kind of thing. So I am expecting not a whole lot. But yeah. Okay, so here we go. So let's track a to-do list. So what do we need to do? Well, today, okay, so I guess we only really have 4 things we need to worry about. Create an audio generator, figure out using Unity at a raw level how we can create some audio effects, and create a node-based graph system, and then connect it all together. Now, I've never worked with audio generation or graph nodes in Unity, so this is going to be new. I guess the first thing we'll do is let's see what it would take to create an audio generator. I'm assuming we're going to need an audio source. But let's figure this out. So I have seen some audio generator scripts. The one I thought was more interesting was this one. So in here was really simple. So let's take that and let's use it as a base and see what we get. Cool. Like I said, I've never really done this in Unity before, so this will be a new experiment for me. Class generator test. Okay. Bum bum. Where were they? Maybe. Let's kind of walk through what they're doing with this. Quiet that down. Okay. So what is he doing in here? Got a frequency, a volume like a gain, increment, phase, sample frequency. So the phase, so that's him changing the increment. So we're taking a gain, which is like a multiplier, and multiplying it across a phase or a position in the phase. I'm not too sure what this data undefined is supposed to be. So I think this code's missing some stuff. So maybe we won't use that one. Let's see if we can find a simpler way of generating just a quick audio source. There we go. Here's an example you can try out. Generates 2 sine waves. Perfect. Sounds like exactly what we needed. We are in generator test. Add the Unity engine. All right. So this is public float. And if we're going to force an audio, just trying to get all the capitalization and camel case correct. Require component type of audio source. That'll ensure that there is an audio source so that when it starts, now we can do a get component. Don't want to actually force 2-dimensional sound. Okay. So they're using spacebar to make noise. They're taking on filter read. Creating a sine wave. With data. Increasing the time. Resetting the time index. And doing a sine wave. Okay. So that looks actually pretty straightforward. Boom, clean up. So now, if we add generator test, it adds the audio source for us. Give those some kind of defaults. 500 is probably too small, too low to hear, but we'll give that a go. Let's see what happens. Well, we made noise. I didn't say it was going to be attractive. Oh, we made some noise. Let's go ahead and create a audio mixer. And that audio mixer will add a sound channel, and I'm going to be able to drop it to -10 generator audio mixer. Cool. Interesting. So we're able to make noise. Just by adjusting these. Cool. Well, that kind of works. BPM 2 seconds. So beats per minute. So we'll call this BPM. I'll call it BPM for now. But we need something now to give us a tempo, because otherwise it's just going to make noise and not adjust. Would sure be cool if instead of making noise that's consistent, if there was a tempo that we could use to kind of set that. So. Keep it something like that. It should give us the BPM with a slider. Good. So BPM formula to seconds. It's probably just times 60, right? Yeah, so that's milliseconds. So gotta make that a float now. Divide that. Let's actually times that. BPM. Cool. So, is there anything else we need to know? Probably not. So, how do we want to do this? We got a heavy tick, a little tick, a little tick, a little tick. Do we want to go in eighths? Yeah. We do. All right. Okay. Okay. How do we want to do this? I guess. So we can track how much time has passed this way. We can track the seconds. If timer is bigger than, get seconds. And subtract 1 second. No. So okay. BPM steps equals 8. Now that's going to trigger at the end of a duration. So we need to start it. So if that equals BPM steps, set that to 0. Okay. So now we'll hit play. This should, hopefully, well, it worked on the first step. That's something. So there, we're adding delta time. We're getting the number of seconds divided by BPM steps. If timer is bigger than the duration, go to next step. So oh, that is in milliseconds. I would think. 60 beats per minute is 1 beat per second. I think I was right the first time. Sounds to me like we need more tea. I suspect. I can't prove it, but I think so. Okay. Let's find out. I think that's correct. So if that was 60, that'd be 60 divided by 60, waiting for this to get to 1. Yeah, let's try that. That looks correct to me. If I drop it to 60, it should be 1 per second. Ah, no. That's 60 divided by 8. So if we drop it to a BPM of 10, it should be 1 per second. Yeah? No? That's definitely not right. High BPM should go faster, so something's not quite right in my math here. Okay. So if we had a BPM of 120, that should be no. Therein lies the math problem. Okay. And we said that should be 1, 2, 3. There we go. So now we're getting 2, 3, 1, 2, 3, 4, 1, 2, 3. Yeah. So we got the beats per minute working. So how do we want to do this? There's a couple different ways. One is events. But for now, let's force this through. So set step obviously we're gonna do something a little more creative, but public float void set step and it's go. So now we know in here that we have audio. So let's go ahead. Spacebar is fine. On audio filter read. So we'll do it that way so that at the beginning we can force it to start on 0. It's going to come through and tell this guy, hey, we're on a new step. So for now, let's call this we're just going to do something that gives us a bit more sound control. So when it's given a step, it sets an intensity. The intensity we subtract decay times delta time. Now, normally we would probably accept a BPM in here as well. So let's do that. So now we have a volume and a BPM. We're going to subtract that times decay times that. Let me think about where this needs to go for the 2 halves. No working on Christmas. Just messing around with audio, nothing fancy. So, okay, so I've got a BPM. Where do I want to subtract that on the math formula here? Yes, thank you. Merry Christmas to you too. Hopefully having a good Christmas. Some new presents maybe. Did you spend some time with your puppy? I know Albert's downstairs. He's adamant that this holiday is for him. Okay. BPM. Right, so I want this intensity to decay over time, but I want that intensity to be based on the beats per minute. If the beats per minute are... Okay. So we can convert a BPM to seconds, because 1 over the total equals n over that, so that... Okay. Let me get this first. So we have a decay rate. So let's look at this as an equation here. Okay, so our total duration of 1 is based on the total bits per second. So we need to get x, we need to x times so this divided by decay. Okay. Because it should be this times this divided by this, I think k. This, so 1 times decay. It's been a while since I did some ratios. So 1 times decay divided by this. And because it's 1 times, that doesn't matter. So that should subtract our intensity. So if I hit play. So yeah, let's see. Brent says, took my puppy to see his cousin yesterday. Oh yeah, we're kind of the same. We my mom's got her cats, and then we got our pup, and then yeah, pretty small families. So the same with us. Okay, let's take a look. This isn't going to show me much unless I turn on debug mode. So we can see the intensity is in there. If we change this to 60, if we change this to 10, so it's 1 tick per second, and intensity is still all over the place. But I might be okay with that. That could be getting caused. Okay, so oh, let me think about this. So we start with an intensity of 1, and we bring it down. So if our BPM's 1, okay, if our BPM is 120, which is twice as fast, so I think I actually want BPM. And that'll give me a multiplier. So now let's go back to the other way. Okay. So that's our beats per second, because if we're at a BPM of 60, oops, gives us 1 second, which is correct. And then if we do a BPM of 10, that's 6 seconds. Is that right? Because 10 times 8. Okay. Let me think this through. A BPM of 120 would be 60 divided by 120, which is half a second. Yeah. Which means a BPM of 30 would be 2 seconds, which is correct. So that's how many seconds we expect it to get from 1 to 0. So and we actually want to be at 0 at this point. Okay, we can do it this way though. So we'll do 1 minus. So that equals right. Okay, well, we'll make the assumption that but we'll fix that later so that it gets fed in here. Otherwise, we're making the assumption there's always 8 beats, and there isn't. So we know that 1 tick, the duration of a tick is going to be this long. So now we need to figure out so if we did it this way, that should fade it linearly. Yeah? Because we take the length of a tick, multiply it by how much time has passed. Yeah? So that should work linearly. Hit play. It's not though. It's subtracting too slowly. And I wonder, so this is in seconds. So if we were to do 60 beats per minute, which is 1 beat per second, so 60 by 60 is 1. And then we divide that into 8 pieces at 0.125. So we know that a tick is supposed to be 0.125 times how much time has elapsed. But this is not 1 based, this is time based. That's why. Am I doing this the hard way? So we know a tick that's not actually BMP per second. That's the problem. That is seconds per BPM. Okay, so we know that's the seconds per tick. So let's assume 0 over n equals 1 over s per tick. So to figure out n, we need to take 1 no. So, okay, we know that we got 1 over seconds per tick. We know that that's right. So on the other side of our ratio, we know this is what we're trying to figure out, and we know this one. So to figure this out, we got to take intensity. So this equals this divided by so I was multiplying it, and it needs to be, and of course the 1F shouldn't matter, so bloody math. Okay. I was not ready for math today. So the intensity is doing something. It's all over the place. Let's get ourselves a more predictable. What was it we said before? That's 1 tick per second. So intensity keeps going to infinity because that is dividing by how much time has passed. And I don't think that's actually what we want. I think that's what we want. Let's see if that's correct. Okay, closer. Man, it's just not doing it quite right. That's in seconds. That's in seconds. Okay. So I think because this is 1 based and this isn't. So the seconds per tick is working out to like 0.125. This is working out to like 2. Okay, well actually if that's at 2, then 0.25. So the time that's gone over and that brings me back to the same formula we just tried. So we know that's 1 based. We know that this is but this is not 1 based. Is it? No, it is 1 based. Okay. So that overall intensity is that divided by delta Is that correct? No. Okay. I think that'll do it. So it is subtracting, it just doesn't get set back to what it was. And that's because time so we reset that counter because we've got a new step. Closer. So we know that's working up to 1. That is working up to 1. So that's a dropping to 0. I think we got it. So going in 1 second increments. That's going up, that's going down. Which means that intensity Let's try that. So if that works, we should get that tied into our bit. That's triggering. That's triggering. So that seems to be too fast. Okay. Giving us an offset allows us to control that a little better. And then we can take the decay. And add that there. But I'm going to want that decay actually more like that. A bit of a clipping happening now, but try slowing this down to 90. Let's try slowing this down to so we can slow down the decay, speed it up, really speed it up. Cool. So the last thing I'm gonna do is invert the two waves. So when one wave gets quiet, the other one gets louder. Let's cut that BPM down to 60. BPM's too low. But you can see now where one is waving and the other one's going the other direction. So that's pretty cool. Excellent. So there's some little things like clearing up clipping. I'm trying to experiment with some effects. But that said, I think for a quick, short little experiment, that kind of shows we have some potential. Then I guess we'll keep it at that for now, but we could come back and store that and start blending them together so that it doesn't have such a jarring clipping sound. We could play with the sine wave. We could change that wave to something more like a square wave. But I'd have to say I'm pretty happy with what we've just created. Doesn't seem like it, but it is certainly usable. The reason it's kind of so chaotic right now is we're going 8 times per beat. So it is triggering a lot more often. If we change this to a 1, for example, now it'll work at a higher BPM because it's going to go on the beat. So if we hit play, knock that to 0. And give that something like 60. it's giving us clicking now at, you know what I mean? Terrible sounds, but I'll consider that a success. So we'll come back and do something more with this down the road, but that was really it. So I didn't want to be on the stream too long today. I just wanted a minute to kind of come on and see how we can start doing some audio generation in Unity with no WAV files, no MP3s, and start funneling it down a tube. So now that we have kind of a base that we've put together, we can come back and start reworking some effects. We got the beats per minute working, and just start tying in how we want things to work. So with that said, thank you so much for attending. I hope everybody has a great holiday. It was a shorter stream today, but yeah, it's Christmas. So thank you so much. Have fun. Bye.